try this again. I am re-recording this tutorial of BGP because as I was actually going through it, first of all, I had an issue with the adjacencies coming up, and then something hit me like, well, maybe this really wasn't the best way of teaching this starting off. Okay, um, so I'm redoing it. Okay, um, and to be honest, this is kind of like a couple of days in the making because um, it's you know I just wasn't happy with the results. So um, you know, not the first time a video has taken me a few days to do, and it won't be the last. Okay, so of course I am unprepared. However, my diagram should be alright, even though it's misnamed, because this is not an OSPF lab, it's a BGP lab. Now, okay, IP schemes are correct. This is not needed, but it's going to stay there anyway. Okay, and what we're going to do is we're going to add um, what are you doing? Okay, and this is going to be no. Okay, so now let's go back to other routing protocols. Okay, GRP OSPF. Okay, so RIP communicates on port. Well, what was it? 520. Um, which is not really important. The bottom line is that's it actually communicates on that port number. Now we can use that as broadcast or multicast, which again is completely irrelevant. Or EIGRP and OSPF uses multicast, but at the same time has a protocol number, which we can match if we're creating a container, because like an access list, all of this is a container of information that we can go down the list to match on, okay, to allow or deny traffic. All right, but if we use something like a route map, which means we're going to match on this particular container of information, and then we're going to set this particular parameter, okay? Meaning that I am going to match on protocol 89, okay? And I'm going to set this traffic to be denied, okay? All right, if you want to look at it from that perspective. When we get into route maps, it'll make more sense. All right, so, but let's take a look. Okay, at what BGP really is. Okay, you saw me put in AS 6500. Okay, so a router, remember, because every router is individually its own entity. All right, same as a switch. A router that sits in AS, okay, or an autonomous system number, because that's what BGP uses in its configuration. Okay, we can actually have a BGP peering with another router that's in the same autonomous system, okay, or in a external or a different autonomous system, okay, all right, and BGP is considered an external or border gateway, okay, protocol, all right. Normally, we would use this as an external protocol. Normally, what we would do is have a directly connected router to our ISP that's in the same BGP, okay, all right, instance, okay, or different, doesn't really matter, okay, but we are assigned a BGP autonomous system number, okay, that ideally, okay, we can use that autonomous system that's live on the internet, okay? Meaning that a internet provider, if you do not understand BGP at a level that is expected you to have as a BGP precipitant, or someone who is being assigned an autonomous system number, okay, the ISP will ban you from using BGP, period. Okay? Alright? And you gotta understand that even though BGP is normally used in this fashion, okay, your internal gateway protocols, your IGPs, RIP, OSPF, EIGRP, okay, all right, that's usually how a basic design is set up. But have no illusions. Having knowledge of this protocol, you do not have to abide to any design standard or best practices or normal behaviors at all. You can use BGP as your internal gateway routing protocol. Okay? So, we also got to look at BGP from a perspective that BGP does not have a routing protocol. All right, meaning that I can't match on a routing protocol, but I can match on a particular port number of TCP 179. Now, what does a web server use? TCP. Okay, but a web server is nothing more than an application sitting on a server. Okay, all right, that web server's port 80 or 443 is being utilized by an application. Okay, and if that's the case, that is how BGP is being utilized. So we can actually consider BGP, even though we are using it to exchange routing information and sharing routes to our BGP peers who are speaking the same language, which will be BGP, okay? We can consider a routing protocol because that's what a routing protocol does. Okay, but in essence, it really is an application. Okay? But that doesn't really matter as long as we understand how this routing protocol, because that's what we're going to call it, works in essence as far as getting the job done. Okay? So, let's go to our lab and let's bring up vSphere here. All right, and let's go to virtual machines. And let's turn on the first two routers. All right, it's good. Obviously, my server is already running. And let's bring up the first three. Okay, so while that's booting, let's go back and let's talk a little bit more about. Okay, so the interesting thing as far as port 179, meaning that any firewall throughout the transit between two BGP routers, that traffic, TCP 179, must be allowed in order for BGP to work. Also, since it is an application, we are going to have to go through the three-way TCP handshake before any BGP messages are even starting to be sent. Okay, that's a big thing. All right, because you can troubleshoot BGP all you want, but if you can't get the three-way handshake established and you're not looking at it from that perspective, okay, you're wasting your time. That should be the first thing you check. Am I sending a SYN packet? Am I getting a SYN ACK back? Am I sending an acknowledgement? Is the other one getting the acknowledgement to solidify that three-way handshake session to be created and established? Okay? Once that's done, that is when your first BGP message will start to be exchanged. Okay? Also, unlike routing protocols that have to be directly connected, BGP doesn't. Okay? Which is cool. Alright? Now, having it directly connected and having it a couple of hops or more down the road is a different configuration. Not that minor, okay? But at the same time, okay, we gotta understand what's going on here. With BGP, when you're directly connected, it's fine because BGP by default, okay, has a time to live of 1. And if you don't know what a time to live is, this is how long a packet can exist in transit before it's dropped. And if you have a time to live of 1, that means I can only be 1 hop away, because the next hop, that router is going to drop the packet because it has a time to live of 1. It's going to deduct 1 from it. Now I have a time of live of 0 and drop the packet. Okay? Does that make sense? So now, but if I'm doing 2 hops away or more, okay, the maximum time to live, okay, which is 8 bits, right, for each octet, is 255. So I have to change the time to live in a BGP packet in order to peer with something that is more than 1 hop away. Does that make sense? This is different if we're using it in the same IS or a different AS as we're pairing, meaning that if router 3 had a 6501 AS, I will have to change the time to live in order for me to communicate and allow that packet to have at least more than a time to live of 1. Okay? Alright? Make sense? Okay? Now, okay, so they don't have to be directly connected. Now, this could also be some issues if you are 5 hops down the road and the routers that are advertising a BGP route to you, the transit routers in between, okay, have to have a route for that traffic in order for it to get to its destination. I might get the route my routing table, okay, but when I send it to my next that router does not have a path for that, and now your BGP is broken. The routes are being shared, but the transit traffic, as you are sending it based on what the routing table is giving you, is broken. Okay, that's one of the bad things you got to be very careful about with BGP. Okay, it is very easy to do. All right, so prepare to understand why you're building this BGP, what you're really doing. Okay, so if you thought OSPF was complicated, welcome to a more complicated protocol. Okay, all right, and this is just the basics. Okay, all right. So that also means that the neighbors do not have to be in the same subnet, like OSPF, okay, and ERGRP, okay. Different subnets you can't peer with. You got to be on the same subnet, right? Okay. And it uses attributes to make its path selection. Now BGP is a path selection routing protocol. Let's take a look at those path attributes. Okay. What this means is if I have 2 ways to get to a particular route, meaning that router 1, router 2 is what I'm connected to, okay? and I can get to it from router 1 or router 2. I can set attributes, okay, that are on this list here, all right, which you see it, there's a lot, okay, to say which path I want to take based on my configuration. Does that make sense? So let's take a look at that route map that we were talking about before. I'm going to match, okay, on this particular route, 1.1.1.1. Then I can get to it from router 1 to router 2. And I'm going to set its weight, all right, to 200. All right, and I believe the normal, the default is 100. Okay, all right, and don't quote me on that. We'll look at it later, and not later like anytime soon. So from that perspective, I'm going to set the weight. So that means every route that's being learned in, that's learned when 1.1.1.1 is learned from my peer coming into my router, okay, from router 1's next hop, okay, I'm going to make sure that that next hop to router 1 takes precedence. Okay? That's what weight does. Okay? Now, weight is locally significant to a particular router. Okay? Oh, I'm sorry. Local preference is default of 100. I can't remember what weight is, but it doesn't matter. Okay? All right? You can figure those out while you configure them. Now, local preference is the same thing. However, it's not just locally significant, because I can say as I'm sharing my route going outwards to my peer, I'm going to set the local preference of that route. Okay, and then my neighbor who's receiving that route will inherit that attribute. Okay, that, you get an understanding why we're calling it a path selected, because you get to choose the path. Okay, and these are how the paths are chosen, because weight will always win over local preference. Okay? Alright? AS, the shortest wins. Means if I have AS 100, 200, 300, and then my next path is 100, 200, it's a shorter AS path. So it wins. Okay? So I can actually change that by prepending ASs to make it worse than the other AS, so my traffic goes the other way. Which again, with a route map. Okay? Alright? So I would say match on this address as far as the route being advertised, and then set the prepend. Okay? Alright? Does that make sense? And I will put like AS100 like 3 times, giving it a 5, or I should say 4 times, so it has 6 instead of the 5 like the other one did. If it was 5, it doesn't matter. Okay? So now, let's bring up our diagram, and let's go ahead. Okay. All right. So, okay. We'll go with this one. Okay, so now, interface. Okay, go over here to router 2. change this to 2. Okay, and do a no shut. Alright, and now I should be able to go over here. And there we go. Okay, so now, one of the things about BGP is, okay, first of all, you gotta have the destination router IP address in the routing table. And since we're directly connected, obviously it's already there because we can actually reach it by doing a ping. So we're good. So now we're going to say router BGP. Actually, we can do it here. Router BGP 6500. So neighbor commands is what we use a lot in BGP. And we're going to say neighbor, okay, 64.1.1, oops, 1.1.2 remote AS, and we're going to say 6500. Okay, we're going to go back to router 2 and change that. Okay, because it even tells you can't do it locally significant as your neighbor, meaning that we're doing it to ourselves. Okay, and there. All right. Okay, and now our BGP is up. Okay. Now we're going to do show IP BGP summary. Okay, now we got our prefixes here, okay, set as 0. Okay. All right, that shows us the BGP routing table, but we don't have anything in there. So what we need to do is say network 2.2.2.2, use the word mask, because whenever you are matching a network statement, it must match the exact mask of that route, whether it's pulled from the routing table, which it is pulled from the routing table, because the directly connected interface is still in the routing table. Okay, all right, mask 255. Okay, and now we're going to create that interface with that mask. Okay. All right. I'm going to go ahead and clear. All right. And still nothing. So let's go ahead. Okay. Oh, I created the wrong IP address. There we go. Okay. So, all right. She's there now. So now let's go over to our other router. Okay. And it is there. Okay. Do show IP route. And it is there as a BGP route. Okay. So now, let us stop right there. And now, let us say neighbor 65.1.1.3 remote AS 6501, which means this is a different remote AS. Okay, now let's go over to router 3. Actually, go to router 2. It's an interface G2 IP address 65.1.1.2 and give it a /24. Say no shut. Okay, now let's go over here to router 3, interface G2. Okay, IP address 65.1.1.3. No shot. Okay, so now do ping 65.1.1.2, and we're good. Now, from router 1's perspective, obviously we're going to have a routing issue, okay, and not be able to get to 65.1.1.3. Okay, obviously. So now what we're going to do is wait until that fails. All right, so IP route 65 1.0 255. Actually, no. This is default route. Okay, interface G1. G1. Okay? Okay, so we're good. So now, ping, do ping 65.1.1.3. Okay, still gonna have a problem, okay, because our return traffic. So we're gonna go back over to here. Matter of fact, we're gonna actually just say do show history. All right, and copy and go ahead and ping again. And we are failing, so let's figure out why. Okay, so that is not, that's not good. Okay, so we need to go back over to here and take a look at our it's nowhere. Okay, wait a minute. This should be a VLAN 2. No. Put that VLAN 5. G2 is going nowhere. So that's VLAN 1. VLAN 1, VLAN 2. Aha. No, that's right. VLAN 6 and VLAN 2. Because it's G2. Okay, I don't know how I got that, but I only got it once. But I shouldn't have gotten it at all. But nonetheless. Okay. Alright, so let's try this again. There we go. Okay, so we're good. Alright, so now back to BGP 6500. And we're going to say neighbor 65.1.1.3 remote AS 6501. And then we can go over here to router 3, router BGP 6501, no router BGP 6500. Alright, router BGP 6501, neighbor 64.1.1.1, remote AS 6500. Okay, now we are not going to do show IPBGP summary to see our neighbors. Okay, all right, and as you see, I have a neighbor. It's 6500, but it's idle. Okay, and it's idle because of our time to live. So to change this, we are going to say eBGP multi-hop and hit enter. Now do show run section BGP. It sets it to 255, which I could have set it to 2, but you know, who cares? But in production, you should care, okay? Because you don't want to allow that time to live to be longer than what it has to be. Security reasons. You want it to die just in case another router is in your is using that extra time to live to manipulate your BGP table. You don't want to do that, okay? All right, but for our lab purposes, who cares? So we say this changes the time to live to 255. Okay, so we're still idle. Clear all the instances. And look at that. 64 is up. But here is still idle. Make sure our statements are correct. So 6500, 6501. Okay. Recheck the configurations. Okay, this should be coming up. All right. Wait a minute. Hold on. Hold on for a second. Great. You gotta wait for it. All right. So to get rid of that annoying thing, because it just wastes his time. All right. That takes care of that. Okay. So we don't need anything on here. What is going on? Let's go ahead and clear it on this one as well. Okay. Well, what is causing this to act like this? Technically, guys, that's all we need. '65, '64. Okay, let's go over here and hey, let's let's say all. No route to peer. Yeah, there is. Active open, no route to peer. Okay, so let's put one in. Well, that's interesting. And my neighbor just came up. Huh. Well, apparently the default route, okay, did not, uh, was not sufficient. Okay, so now, okay, so first of all, let's turn that off. Do uh, 6501 network mask. Okay, do show IPBGP. Okay, it's there in its table, and now let's say do show damn caps. Okay, and it's there. Do show IP route. Okay, do ping 3.3.3.3. Okay, so now here's the thing about BGP. It's considered a slow protocol. And it's done that way by design. Because the internet probably has over 1 million routes, and I'm not kidding. Because at one point it was 800,000, and that was years ago. Okay, so I'm sure there's like 1 million routes now in the BGP routing table of the internet. And can you imagine if BGP was really fast? What would happen if a route was bouncing? Okay, injecting, exiting, injecting. Okay, it would cause havoc on a major scale. So BGP takes its time. Okay, and it takes its time by design. All right, now the static route, from my perspective, should have been sufficient, but apparently is not. That's why we have debug commands. Okay, all right, especially in our lab environment. All right, doesn't mean you can't use them in production, because I use them all the time, but it's frowned upon, and it's not something that I would, go around bragging. Oh, by the way, I use debug commands on all our aggregate and edge routers. Okay, that's something that you want to brag about. All right, it's definitely something that, from a troubleshooting perspective, um, if you screw up, all right, and lock yourself out of the router, yay, you shouldn't have been doing the debug commands in the first place. All right, so, but in the lab environment, of course, so on and so on. All right, that's kind of, I wasn't expecting that. As long as we had a route to send the traffic, but BGP, again, it's its own entity, and it has its own rules. So apparently, it did not like the fact that it was receiving a message, but it would not respond because the destination was not in the routing table. It did not have a way of getting to the next hop. Okay? Alright, once I put it in the routing table, we were good to go. Alright, and the parent came out. Alright, so remember, as we are hopping past one that's not directly connected, okay, we set up two routers that have the same autonomous system number. That is called IBGP. Okay. All right. We also set up with router 1 another connection to a router that was 2 hops away, meaning that we had to add in the eBGP, which that's what it's called, because we're connecting to a different AS. That is called eBGP. I is internal, E is an external. Okay? All right. So with the external BGP by default is expecting your neighbors to be, okay, directly connected. If it's not, we need to change the TTL for that behavior. Okay? Alright? Now, IBGP, don't quote me, do your own research. I believe IBGP already has a a TTL of 255, I believe. Okay, because internally, it doesn't really care. It doesn't really care about it have. There's no security issues when you're doing it internally. Okay, because internally means that you're doing it with your same AS. Okay. All right, and I'm gonna look that up on the internet real quick. Okay. IBGP. Time to live. Yeah. Okay. So the required TTL values IP headers will be 255. Now that is. I thought I said IBGP. Okay. So IBGP is 255, and then EBGP. Okay, is set to 1. Okay. So that's why originally, okay, originally I had issues with my first video. Okay, it was a failure because I started off with router 1 and router 3 and not explaining, okay, the differences of having just a directly connected connection with IBGP or ABGP. I just went right off the ABGP, skipped the whole IBGP thing, okay, and it just was not thorough, okay. So this is just bringing up a neighbor relationship, and as you saw, I had an issue with just that, okay, all right. But I know, all right, that that's the only configuration that's needed. So it had to be something else, and I didn't know what it was. I couldn't even guess, okay, because I have reachability between the two peers, which is all you need. But that's not the case with BGP. Sometimes things have to be in a routing table, okay, all right. So again, all right, that's the basics of BGP starting off, okay, all right. And I don't know exactly. I think I believe BGP with that. I'm gonna go back through my information to see if there's anything else I want to cover. Um, because we haven't even gone through route filtering yet, or even path selection with the other routing protocols. So this is really the basic of setting it up. Okay, of getting it set up. All right, so everything's going to be used with the neighbor command, okay, and so on and so on. But as far as the complicated protocol, BGP wins that trophy across the board, from my perspective. And I'm sure every other network engineer out there. Okay, so now, um, that's pretty much it. And guys, I'll see you next on the next. I will see you guys on the next one.